Hello, welcome back to Cracking the Cryptic. Now, I have got the pause button on hold here because the workmen in the flat below are being sporadic and unpredictable would be how I would describe it. They are making some noise very occasionally, but sometimes very loudly, and I have to try and record, so there may be a pause. But that would be a shame, because I'm looking at a very interesting puzzle called Eye of the Beholder by Osgood and Calvin Ball, who have collaborated on this. Calvin Ball does a lot of collaborations, I think. We've featured some of them on the channel before. So they always turn into very interesting puzzles from experience, so let's hope that's the case again today. Don't forget that on Patreon, coming up 1st of June, we're going to have a new Alien Invasion Sudoku hunt. We would love you to participate. Some very interesting puzzles based on some surprisingly secret documents released by the US Department of Defense. And yeah, who knows what they represent. We think you can solve them as Sudokus, and we'd like to give you a chance to try. They're a little bit easier than last month's, if that's any incentive. Hope it is. Do join us on Patreon, where there's, I can hear the drilling, where there's extra videos, connections, gridogram, and some crossword videos each month, and lots of intriguing puzzle content. So check it out. Also, of course, we've got the Worms, including Zeta-Math's new Worm, 6x6 puzzles, I think, and great fun in his Snecko Worm. You will be able to complete it, as long as you remember that you may not be able to complete each puzzle until you've looked at the next one, and then you can go back and finish off. It's great fun, it's really clever, and I commend it to you. We've also, of course, got, as well as the Worms amongst our apps, we have Arrow Sudoku and others, and they're good fun too. Then there's merch. You could get some t-shirts, or, I mean, good for this weather that we're having in the UK, if that applies to you. Get yourself a Cracking the Cryptic t-shirt and show off that you know the brand. It's good fun. Anyway, let's have a look at the rules of Eye of the Beholder. Obviously, that's where beauty lies, in the eye of the beholder. And it kind of suggests to me that some people do like this puzzle and some don't. I don't think that that's likely to be fair. I think they're going to be very modest, if that's what Osgood and Calvin Ball are suggesting. Let's have a look at the rules. Normal Sudoku rules apply. 1 to 9 in every row, column, and 3x3 box. Each question mark acts as a stand-in for a digit, which must be deduced for each question mark. Each circle, therefore, contains 2 digits. The 2 digits must appear each in at least one of the 4 cells surrounding that circle. If a digit repeats in a circle, it must appear twice. Digits along an arrow sum to a 2-digit number, and that number is a concatenation of both digits in the attached circle. And then there's a clarification that, for instance, a circle with the digits 1, 9 in it would be surrounded by at least 1 copy each of the digits 1 and 9. And could have arrows that summed to either 19 or 91. Its arrows couldn't sum to 11 unless there were also 2 1s around that circle, or the same for 99. So I think those rules are clear. It's an intriguing idea, not one I've seen before, certainly not with the question marks. And I'm going to restart the puzzle now. I'm going to warn you again that I may have to pause at some point for noise, but you will hear the noise and understand why if that occurs. Let's get cracking. So, the only enclair circle, in fact, the only enclair question marks in the puzzle are in this circle. And these arrows will add up to 14. Is 41 even possible? Actually, it is for this one. This could be 987 plus 98. So we have to remember, just because we're reading 1, 4 in reading order, the rule set was very specific that we might be looking at a concatenation in either order of the numbers. So this could be a 41 arrow. I think it's likely to be a 14. Now, we also know that 1 and 4 are surrounding these cells in this box. This arrow definitely adds up to 14. I'm just going to mark it. Because, I mean, the maximum that you could get on that is 9, and a 9, 8 is 26. You can't get up to 41. I have to say, I'm studying this grid now for the first time. I am, frankly, very puzzled that this is a solvable Sudoku. How on earth are we going to narrow down these question marks? Maybe by working out where ones are. Look. This is a 2. I hadn't seen this 2-cell arrow. Oh, well, okay, I've got a digit. That 2-cell arrow is clearly going to add up to no more than 18. It could have 2 9s on it. But its units, its tens digit is a 1. This arrow, we know we've been told there's a 1 in those 4 cells, and there needs to be a 1 in these 4 cells now because there's a 1 in one of the question marks. So that's in the overlapping spot, and there's the digit I've got. I mean, it's not rocket science, let's be honest, but it is true. Oh, but that, well, I tell you what I'm going to do. I'm going to mark this arrow in the light blue, and I'm going to now designate that light blue means arrows whose total begins with a 1. Because I can mark this one that way as well, because at maximum this could be 9, and 9 and 1 is 19. So this circle needs a 1, doesn't it? Because if this is maximum 19, its total is 1 something, and then 1 is one of these arrows, and we need to put a 1 in one of these cells. As long as I've understood the rules right, that's what's going on. Now there's a 1 in one of these cells, and what that means is there is not a 1 in one of these cells. And yet, what is this arrow going to add up to? Oh, this is very good. This arrow is going to add up to 20 something, obviously. If there's not a 1 in its 2-digit total, it must be 20 something. And it can't be 20 or 21 because we still can't put a 1 around there, or 22 because that would need 2 2s and we're in the same box. So it must be 23 or 24. And these digits are 986 or 987. And there's definitely a 2 around this circle. This is now where 1 has to go in the box. That's actually going to keep 1 off this arrow, which might be interesting. But I'm more interested in this arrow now, which doesn't have to add up to the same total. But I think perforce it's going to have to. Because this arrow at least does have to add up to 20 something. And that 20 something, yet again, can't be 20, 21 or 22 because of what digits we can put here. So it does add up to 23 or 24, hang on, or 25 or 26. Because you can have a repeat digit on an arrow. We could put 9 on both of those and get to 25 or 26. Now, this digit cannot, I'm going to say this digit cannot be either a 2, because the maximum you would get to is 19, or the units digit of its arrow, because then the other 2 digits would have to add up to 20, exactly 20, and those 2 can't. So this digit is not the units digit of its arrow. The units digit of its arrow is sitting in one of these cells. Do we know? Yeah, we do also know it's not the units digit of this arrow, because it can't be 3 or 4, because that couldn't add up to more than 21. So these digits are the 2 as a tens digit and the 3 or 4 as the units digit of both arrows now. So this one adds up to 23 or 24. Now, the minimum for those cells is 9, 8, that's 17. The minimum for this cell is a 6, isn't it? Sorry, the maximum, I think I said minimum. The maximum for those cells is 17. The minimum for this to get to 23 is at least a 6. So now we've got a 6, 7, 8, 9 quad in the box. These cells include a 5 and not a 2 and come from 3, 4, 5. Now, can we go further? If this was... Oh, if this was 24, I was thinking 23 would be the problem version, but no. If this was 24, those digits would have to be 7, 8, 9. This would be a 6, and these two would have to add up to 18 to make it up to 24. And they cannot do that because they both have to be 9s. So 24 is the version that's impossible here. This is 23. For both arrows, it's 23. Neither of them's 32. Don't go worrying about that. So if it's 23, these three are 6, 8, and 9. That's the only way we can add 3 different digits up to 23. This is now a 7 by elimination. These add up to 23 minus 7, which is 16, and they have to be different from each other, so they are 7 and 9, and that lets me place 9 back in box 2 and get a 6, 8 pair. This is lovely. This puzzle is beautiful. I don't care who the beholder is. This is beautiful already. I mean, it may continue being utterly beautiful, and I suspect it will, but let's keep going because it's fun, actually. Now, oh look, there's a 9 and a 7 in these cells. Now, what is this? We said this couldn't be 41. That's too high. So it definitely adds up to 14. And look, it doesn't use 1, 2, or 3 in these cells. So they're an absolute minimum of 4, 5 is 9. That gives us a maximum here of 5 to make the arrow total work. Now, these are not 4, 5 because we've got to fit 7 and 9 into these 3 cells. So at least one of these is 7 or 9. That is going to make the minimum total for these cells 7 and 4, which is 11, and the maximum total for this one, 3, to get to the 14 total. That's quite useful. Oh, I'm going to have to pause. Excuse me a second. Sorry about that. I think the danger has stopped. Now, I was saying that one of these is at least a 7. 7 and 4 is the minimum. That digit must be 7 or 9 as a result. 7 and 4 are the minimum. 11. So this is either 7, 4 or 7, 5. We can't have a 9 there because to get to 14 we'd need a 2 or a 3 here, and we can't do that. So forget 9 in those cells. That's the 9. 7 is definitely in these. And it's either going with a 2 and a 5 or with a 3 and a 4. Well, that's good. Now, these digits don't have 7 in. They're from 4, 5, 6, 8. They must include 6 and 8. Yeah, I don't know. I mean, I'm looking at this circle, this one. They're not that helpful, if I'm honest. This one, I don't know. Obviously, all of these circles begin with, well, I was going to say a 1, a 2, or a 3. I'm not absolutely certain that one of them couldn't begin with a 4 somewhere, but they're not easy arrows to deduce, I don't think. So, what is the next thing I do? I know 4 is in one of those cells because of the quadruple clue. Oh! This thing, this is now struggling a little to be 14, is it? Because of that 2 or 3, don't these have to be a minimum 2, 4, 5 now? That's what they might be. They might be 2, 4, 5 with a 1, 2 pair here. No. No, they can't be that. That's beautiful. It is not in the eye of the beholder, Calvin Ball. Right. Why can this arrow no longer add up to 14? Its absolute minimum here, given that 2 or 3 is there and 1 is here, is 2, 4, 5 in these cells. which adds up to 11. That would absolutely require these two to be a 1-2 pair to get to the 14 total. Now, if those two were a 1-2 pair, look at this circle and arrow and work out what its tens digit is. Because if you're going to tell me it could be 30 something, I'm going to tell you no. The absolute maximum for this arrow's total, actually, that was worth doing. The absolute maximum for this arrow's total now is 20 with 9, 8, 3. And it can't be 20, that would require a 0. So the circle total has a 1 in it. And I can say that there's a 1 in one of those cells, and now there's a 1 in one of these. And now there can't be a 1 on this arrow. And this one, that's incredible. This one can't add up to 14 anymore. So it must add up to 41. And we worked out how to do that earlier with a 987 triple and a 98 pair, which adds up to 24 plus 17 is 41. And this must be occurring. So then there's all sorts of Sudoku. We can place 7 in the central box. We can sort out that 8-9 pair thanks to this 9. This digit's not 8. I mean, this arrow is done. Well, no, it's not, because, well, this arrow is done. The other arrow from the same circle is not complete. But this central box, we've now had 8, 9, 7, and 1. Oh, that's where 4 goes because of the quadruple. And these digits are from 2, 3, only one of those, and 5 and 6. And there's a 1 over here. This, okay, that 1 is interesting for this circle, which must add up to at least 20 something. I think it has to be 20 something. To get to 30 here, you would need 9876, and you'd be using a 0, and you can't have 9. 8765 is the absolute maximum here, which adds up to 26. And if we can't use 1 as the tens digit, we're going to use 2. That doesn't quite limit what's going on the arrow, I don't think. This one's interesting, is it? Yes. Oh, beautiful. This is very interesting. Right. This digit can't be 9, 7, or 8. Its maximum is 6. This one's maximum is 6. What is the minimum total for the arrow, given that we can put a 1 on it, but not another 1? It's 12. So that must be happening. It must be a pair of 6s and a 2 to say that this pair of question marks add up to 12, or are 1 and 2. So that is done. This is now not, oh, well, this is now a 3. In fact, that's going to ramify onto this arrow, where we know it adds up to 14, and therefore we're using 7 and 4, I think. And that takes 4 out of these cells, and 6 is looking at that cell now as well, and that becomes 5. Oh, and this arrow might have implications from that. 5 plus 2 or 3 gets us to 7 or 8. Oh, look, this number can't be 9, 8, or 7 now either. Its maximum is 6. That gets us to a maximum total for this arrow of 14. Okay, I was excited by that, but I know where to put the 1 now. I can't put it here because the arrow could only add up to a maximum of 9, and it's got a 2-cell total. So I'm putting the 1 there. Then I think this is now, it can't be oh, it could be a 4. It's 4, 5, or 6. And the total for the arrow, frustratingly, is somewhere between 11, well, it's not 11, but it's 12 to 14. And that doesn't really help. I can't pencil mark that even. But here I'm selecting from 1, 3, 4, 7. Oh, this arrow is getting a bit fulfilled as well. 6 already there. What? Oh, hang on. 2 is looking at this cell. So this can't be 1, 2, 3, 7, or 6. This is 4, 5, 8, or 9. And the arrow total is either 10 or 11, both impossible. Now it is either 13 or 14. So there's either a 3 in one of those cells or a 4 in one of these. No, I've done my maths wrong. It's 14 or 15. So there's either a 4 or a 5 in one of these cells. Right, by Sudoku, these are from 2, 6, 7, 8. That one can't be 6. This doesn't have a 1 on its circle, which is hardly surprising. Oh, it also doesn't have a 3 on it, which is a bit more surprising. There's a 3... Oh, here comes the drilling. I'll just pause for a bit, sorry. Okay, hopefully that was the end of the drilling. I was going to mark 3 in one of these cells. That's not the end of the drilling. Sorry. Right, we'll resume again and hope that that was the end of it. What was I saying? 3 is in one of these cells, so it's not the tens digit here. Can it be 40 something? No, look, we've got, well, there's a 1 in one of these cells down here. And these are from 2, 3, and 4 up here. The maximum these two can add up to is 5. The maximum here is obviously 30, and even that couldn't be achieved. So the tens digit must be a 1 or a 2, and it can't be a 1, so it must be a 2 in one of these cells. That's good. Oh, hang on, is there an impossibility if these... Do these have to include 6 now? No, maybe not. I thought this was creating something. I don't think it is. Anyway, it's 20 something. It's a little hard to figure out exactly what it's doing, if I'm honest. Oh, let's come back to this one though. This one, what did we say? 5, 7. Oh, well, that's got firmed up in a way I hadn't realized. This can't be 4 anymore. This is 5 or 6, and this arrow is now adding up to 12 or 13. So, there is a 2 or a 3 here. And that's a virtual triple of 2, 3, 4. No, it's better than that. It's a virtual pair in this row of 2, 3, isn't it? Again, that feels a bit weird. I might be mistaken. No, I think that's right. There is a 2 or a 3 in this ambit of this circle, so that we can make its total 12 or 13. And that is the other digit from 2 or 3. So 2 and 3 must be forming a pair in that row. That not only gets 2 out of those cells, it makes this one a definite 4. And that takes 4 out of these ones. And 1, 4, 2, 3. This has to be 7 because it can't be 2 or 3 based on that triple. And that takes 7 out of all of these cells. Yeah, I don't know. These are from 2, 3, 5, or 6. I probably can't do much more at the moment. Oh, I can do something. I can interpret those two. If that's a 5, there's a 2 here and that's 3. If that's a 6, there's a 3 here and that's 2. So weirdly, those two cells add up to 8 for some reason. Now, I haven't looked at this one for a while. This is down to 2 possible digits. Oh, I have looked at it, have I? 14 or 15. Yes, I have looked at that, and it hasn't really changed. Okay, how about this circle, which I've never looked at? Or this one? Oh, this one's interesting. This one's interesting. What is the maximum here? Previously, I'd said it was 8765, but that is no longer the case because of this marking. So it's 8764, which adds up to 25. That is also the known minimum for the 2 question marks, because we can't have 1, 3, or 4 in those places. So it must be a 25 arrow. These must be 8764. And that can't be where 2 goes, that's where 2 goes, and this arrow adds up to 25, so that becomes a 5. This puzzle is gorgeous. It really is gorgeous. Absolute stellar quality. There's a 9 in one of these cells, and that digit, whatever that is. And in this column, we've got 1, 2, 3, and 5 to go. Actually, look, these two cells, they also are from 1, 2, 3, and 5, because they see 9, 7, 6, 8, and a 4 in one of those. So we've got ourselves a little 1, 2, 3, 5 quad. There must be a 4 over there. These are known now to be a 6, 8 pair, like those and those, I think. Does that affect these? Probably not. Now, I'm getting a bit scared of these long arrows because they seem so vague and unconstrainable. Let's do some Sudoku instead. There's a 1 in one of those cells. This corner cell must be 2 or 3. In fact, in this row, we've had 7, 4, 5, 9, 6, 8. Everything else in the row is from 1, 2, 3. That's done, basically. This one is the one I haven't really finished off. Yeah, all of the other arrows, I mean, obviously there's that pair adding up to 8 still to complete that arrow. That's fine. Okay, I'm going to have to look at this one, I think. It's got a 1 and either 2 or 3 here. It's got a 2 and some other high digit here. I don't know. Let's look at this column. Right, these digits are from 1, 3, 4, 5. The 1 has to be on this arrow, I think. Yes. Two and 7 are definitely here. I was going to say these are from 6, 8, 9. That's not only not necessary, it's not even true, because one of them is 4 or 5. Oh, 6 is looking at that cell, and that's the digit that's going into one of these with 9. So one of those is a 6. Ah, 5. That 5's huge. Right, that's taken 5 out of these cells and put it in here. And I remember that my 2 yellow cells had to add up to 8. So that's to make sure that this 12 can have a 2 on it, on the circle. So there we go. That's done. The coloring's absolutely pointless, really, isn't it? I'm going to get rid of those blues and just leave that as an incomplete arrow, and that one and this one, which I've barely looked at. But we're making good progress. We've now got a 2, 6 pair there. That can't be 6, and this must be 6. Taking out the corner mark. Okay, I'm going to have to look at pinky arrow. Now, hang on. That's not 2 or 5, so we've got a 1, 3 pair in the column. So these are from 4, 6, 7, 8, 9. Well, that might help looking at pinky arrow. Or it might not. Right. What is the tens digit? Surely it's not 4. The maximum those could add up to, I mean, it's 30 in any case, 33. Yeah, the tens digit is not 4 or 5. It's this one. Now, can it possibly be a 3? If that was a 3, these can't be 9876 because of that cell. They could be 9865, I suppose, in the extreme case, which is 28. Plus 3 there would get us to 31, but that won't do because you couldn't get the units digit into this group then. So this is not a 3. We can't get up to 34 as a minimum. So that's a 1. And I mean, that's good. That's good solving. That's something that we've learned. Now, that is also the tens digit now, because now that 3's gone, it can't be the tens digit anywhere here. So that is the tens digit. So now we're looking for as low a total as we can manage in a way. The minimum for these two is a 4-6 pair, I think. That's 10. The minimum for these two is a 2-3 pair. So 16 is the minimum total for this arrow. And that means this is the units digit around this circle. That green cell is the units digit. We're getting to a total of either 17, 18 or 19, including the 1. Now, what else can we do, if anything? 4, 6 here, plus a 1 there, is 11. These have a maximum total of 8 now. I was hoping to rule 6 out of either of them. Ah, look at this cell. If that was a 7, this would be a 6, 7, 8, 9 quad. And these would have to be very low, from 2, 3, 4, 5. Ah, also, if that was a 7, this would be a 4. And these would now have a minimum of 13, plus 1, 2, and 3. Wow, that gets us to 19. So it's nearly completely ruled out by this being a 7, but not quite. Oh, hang on, there's a 7, 8 pair here. That not only takes 7, 8 out of those cells, it puts a 9 in this blue one. And that takes 9 out of this cell. But we now add up this blue arrow. It's 15. So it needs a 5 in one of these cells. And this is now not 5 down here. It's got a 1 in one of those two, and it needs a 5 in one of those 3. Okay. It's all to do with the interaction of these blue, pink, and orange arrows, but it's getting harder. Oh no, that 6 is looking at this cell. It's become a definite 4. I didn't expect that. That's now not a 4. In fact, in this row, we've had 6, 7, 8, 9, 4, and that sees 1. That's 2, 3, or 5. Everything else in the row is again from this 1, 2, 3, 5 group. Ooh, what are we getting up here? Not quite enough. Oh no, what are we getting in this box? We're getting a 1, 2, 3 triple, and that digit's 5. That's lovely. Oh, well, this is just Sudoku. Excellent. So we take 5 out of those cells. Now 5 must be in one of these two to be around this arrow, this circle. And that means that's not 5, and one of these two is 5 in the bottom row. Now, have we done anything else? That's definitely 2 or 3. So this, what's going on this arrow now? Well, I'll tell you what's going on in the column. That's become a 7, and that's a 4. And so we didn't get our quadruple of 6, 7, 8, 9 there. We need a high digit down here somewhere. Okay, if this was a high digit, 6, 7, 8, or 9, these would be minimally 13, 17, 18, 20. That's no good. That's too high for this 2-digit number. So this is not 6, 7, 8, or 9. This is in the column, and this is 2, 3, or 5. It can't be 4 or 1. And where else am I forming doubles and triples? I've got a quad in this box. I thought I'd be using that more. I can't see how to use it, but it's happening. Something's happening. We're going to get this. Now, 2 and 7 are down here. 5 is on this arrow now. Oh, let's think about the 1, 2, 3 triple. Yes, hang on. That left us with 4, 7, 8, 9 still to place in the box. I know I'm pencil marking every cell. I can't help it. I need it. That's 2, 3, or 4. That's 1, 2, 3, or 4. Now, other things may have been going on in the Sudoku of this that I haven't really been noticing. These don't have a 1, so these do. Okay, let's look at this arrow again. Absolute minimum, 4, 6, 2, 3 pair, and 1. That's only 16. We need more than that. Oh, that can't be a 7 by Sudoku, nor can this. That hasn't placed 7 in the box, has it? Don't think so. I don't know. I feel like there's more done and I'm just not getting it. Oh, that's a 2, 3 pair in the top row, so that's a 1. That does, no, it stops that being a 1. Yeah, that's a 2, 3 pair in row 7, so that's a 1. And is that in an interesting position? No, it's not. It does mean, oh, 3 there has meant that this is a 2, 1 pair. So now we know quite a lot of digits on this. There's a 1 and a 2 and a 5. That adds up to 8. And a 2. That adds up to 10. Then there's another digit in these cells. And another one here. We're up to 10 only. And we need a 6, 7 or 8 here. And something here. Have we got a quad in this row or a triple or anything? Oh, look. Is this a 1, 2, 3 triple? It is. This is a 1, 2, 3 triple. This cell can't be 3, 1 or 2. Oh, hang on. No, I'm wrong, because this can be 3. So I'm wrong about that being a 1, 2, 3 triple. Bother. Okay, well, at least I spotted it. Okay, here's another thought. If this digit was 3 or 4, this would be a pair of 3 or 4. And this group would either be 2, 5, 6, 7 or 2, 5, 6, 8. And we can work out what they would add up to. It's either 20 or 21, plus the 3 here is 23 or 24. That would just determine what this was. Okay, that didn't quite work out. Oh, gosh. I mean, there is still some interaction between pink and orange, isn't there? Oh, am I missing Sudoku? I'd hope I am, because this is quite difficult now. No, I don't know. I'm looking down columns 1 and 2, columns 4 and 6, hoping to see something that I haven't noticed. I mean, these are from 4, 5, 6, 8. That one can't be 5, we know. Oh, goodness, I need to find some other little thing. There's a 9 in one of those two cells, so that can't be 9. That is a very little thing. All that does is put a 9 in one of these, which I think I sort of knew anyway. Oh, how about 5? Well, no, first of all, let's try that being a 2, 3 pair. Then these add up to 10. Then that digit would therefore have to be the units digit that appears in green. Yeah, that's quite interesting. If that's a 2, 3 pair, the other cells on pink add up to 10. That must be the same as that. And then it would have to appear in one of these 3 cells, so it would have to be 9. Okay, I'm not saying that we've done anything, but it's interesting that it resolves things, apparently. If this is not 2 or 3, it's obviously 5. And then this arrow, then those add up to 10, and those two together have to add up to this. And what we've now discovered is this digit can never be 7. If this is 2 or 3, we're adding up to 10 plus that. These two have to be the same and the same as that, and this has to be 9. If that's a 5, we're already up to a minimum of 18. This green can never be 7. So that's an 8, 9 pair. I mean, it causes a deadly pattern, but that's going to get resolved somehow. We can put a 7 in here now. 8, 7. That 8 comes out of these. That's a 6, 9 pair. This is 7 in the box. This is 8 at the top and 6. Now we have to make these. Oh, we don't know still whether that green is 8 or 9. So, okay, I'll hold off on declarations here. That 7 is going to place 7 over here. 6, 9. Right, now surely we can rule out either 6 or 9 here. If this was a 9, then we're up to 14. Then they would be 2 and 3, and that would be a 9. If this was 6, 10, 11, these would either add up to 7 or 8. So if that's a 6, this is a 5. If that's a 9, everything's fine. This would be 2 or 3. Okay, that doesn't resolve it. Is there Sudoku? Or do I have... No, I have to probably work on orange now. It's very clever, this, isn't it? Right. There's definitely a 5 in one of those. That's not helpful. I want to get some Sudoku to narrow this field down a bit, and I can't find any. I'm annoyed. Okay, we know there's a 5 here, and a 2 here, and a 2, 1 here, and they add up to 10. Then there's 2 other digits to put on here to get to 20-something. And the 2 other digits, can they involve a 3? Only if that was an 8. Yeah, they can't involve a 3. I'm going to make that strong claim. This can't be a 3, because that would be a 5. We'd have... Is that the drilling again? Oh, I'm going to have to pause. I'm sorry. No, they've stopped. Let's hope I can carry on. Right, those bits would add up to 11. Plus 2 there is 13. 6 wouldn't get us to a 20 total. 8 would only get us to 21, and we can't do 21 because we can't put 1 as a units digit around here. So that's not 3. Oh, I will pause now, sorry. Right, I'm going to try and complete this in between drilling sessions. So annoying. Now, we took 3 out of those cells, so this is 3. There's a 4, 5 pair there to sort of prove it. That 3 comes out of these 2 places. Now, if this is 2, that's definitely 3. I don't know. I don't think that's eliminated anything conclusively. Okay, this though has 3 possibilities, and all will leave a definite arrow total. So, in fact, what I'm going to do is add up all of these digits. 2, 4, 5, 6, 8 add up to 25. Plus those 2 is 28. And then we take away this. So if we took away 8, it would be 20, and we can't use the digit 0. If we took away 6, it would be 22, and that would need 2 2s in this box. So that digit must be a 4. And that means, well, I mean, whatever this arrow is doing now, it's right, but let's just check it. We took away 4, and we get 24 as the arrow total, and that 4 is the units digit itself. But that now lets us write in a 5. Do the 4, 5 at the top. This is now not 5 or 4. This is a 2, 6, 8 triple. That 4, this might not finish it, you know. I'm still going to have to do the blooming pink arrow all over again with any tiny change in circumstance. Yes, look, there's a 1, 2, 5 triple in the bottom row. So that's not a 2, and that is a 2. And that's going to determine 1, 2. That's going to place 1 over here, I think. This can't be 1 or 2. That's 3, and there we go. 2 and 5. And now this arrow will only have one conclusion, although I don't remember what it is. 12 plus 9 would be too many, 21. So 12 plus 6 is 18. And there we go. The deadly pattern unwinds. The 9... The 6, 8 pair, that's 4, that's 9, that's 8, this is 3. Let's get rid of the colour because it's done its job magnificently, like a a rainbow of joy. 8 and 6 there, 6 and 2 here. That's 3 in the corner. That's 3 in the spot. Light losing its religion. I don't know what I'm meant to be putting in this cell. 3 or 5. There we go. 2 in that corner. 8 and 6, and then 3 and 5 here. And that beauty is not in the eye of the beholder. It is objectively within this puzzle. That is my view. That is not my real time, although it's a very nice time of nearly 44:44. 44:44 minus some drilling is my actual time for solving. And I realise it's not actually drilling, it's sawing of something very heavy, and it's incredibly annoying, and I will try it and not have to do another video while that is going on, I have to say. I thought they had finished last week, but apparently not. Thank you for staying with me, and thank you to Oscode and Calvin Ball for the puzzle, and I will see you again soon. Bye for now.